Hello everyone, today I will talk about my design solution for the blue-green algae problem in Volcania. I will share from 6 parts: problem, theoretical frameworks and methodologies, design solution, material testing, design process, and design production. People in Volcania use the Darling River as their main water source. If blue-green algae happen and people don't find it early, it will hurt their life and health. If humans touch or drink the toxin from blue-green algae, they may have skin and eye allergies, stomach problems, and even liver damage or other health problems. So my target people are the residents in Volcania. This is my persona. She is a woman living near the Darling River. She has 2 children and works as a teacher in the local primary school. Her main goal is to make sure her family and students drink safe water. But her problem is that news and government warnings come too late, and sending water to a lab takes a long time and costs a lot. So she cannot know the result quickly. Next, I will talk about the theories and methods in my solution. First, it's sustainable design and cradle to cradle. The aim is to reduce waste, encourage recycling, and make a closed loop for the package life cycle. Second, it's information design and facial literacy. The aim is to let people with low education also can get water safety information. Next is the final design response rationale. I found that home testing for blue-green algae is easy and fast, but the accuracy is not always good. Lab testing is very accurate, but it takes time and costs more. So the best way for Volcania people is to use a commercial test kit. It can give results in 50 minutes, and the accuracy is between 1 microgram L and 100 microgram L. But I found these kits use normal designs and the instructions are too much text. So I want to design a new package. The package will combine the instructions with the box, and I will redesign the package and make the instructions visual. Here is my sketch. I choose a chalk and box as the package structure. The steps for using the kit are printed inside the box. The step pictures mix a clinical style with Volcania cultural style. I also make some parts bigger to make sure the information is clear. Next is my material testing. I tested the paper thickness, folding ability, and texture. I tested 10 types of paper. In the end, I chose 310 gram seed paper. It's easy to fold, not too thick, and good for the environment. It fits sustainable design and C2C concept. And here is my design process. I made 3 versions of the package. One is the basic design, one uses a cardboard effect, and one combines Volcania culture with the package. This is the structure improvement. Before, I printed the steps inside the box, but now both versions let users tear off the manual along a dotted line. The first version is a single sheet stock inside the box. The final version is a folded manual, glued on the left side inside the box. Here are the 3D models and the renderings of both structures. Here are the final effect picture. On the bottom of the package, I added a result guide and safety notes. I also improved the shape of the manual. Finally, these are the photos of my real product. This is the process of the opening steps. And this is a picture of tearing the manual along the dotted line. And finally, this is an interactive display using the detection kit. Thank you for listening.